Nice, let's get started. Welcome, thank you for coming. Show of hands, who's here to just save a seat for the keynote? Be honest. I know you are. Okay, Eventsourcing, you're doing it wrong. Actually, I wanted to submit this title. You're doing it wrong because I know obviously best. I've been working on those systems for a couple of years now, and then I realized that I know nothing, because this is a really complicated topic. Nothing works really out of the box. So there's a third title. Event sourcing, you're doing it wrong, maybe in some parts, because we made mistakes, and so will you, and there are no easy right-wrong answers, and everything is difficult, nothing is really black and white. But if you try to submit this title to a conference, you get rejected. So let's settle on the final title. Maybe, probably, you're doing parts of it wrong. So that's that. Who am I? I'm David. I'm from Düsseldorf. I'm a big fan of Fortuna Düsseldorf. Best football club. Nice. Thank you. And if you want to link up with me, you can find me via König Hotze. It's a long story why that acronym. You can find me on Twitter, on GitHub, on PlayStation, Switch, whatever you want. I work for a German consultancy, Senacor. We are really small, just 500 people, and we build large systems for large companies like financial institutes, insurance companies, logistics, so no greenfield Hello World projects, actually. And feedback, you have to use those hashtags, I was told. Quick show of hands before we get started. Who's building microservices in production? So das hat, yeah, Wahnsinn. This has changed. Keep the hands open, up. Who's doing microservices and domain-driven design? Okay, nice. Nearly, I think, 40 people. Are you doing event sourcing? With Kafka? Oh, I would like to talk to you afterwards. 2 people, I guess, or 4. So what are we going to talk about? We are talking about typical misconceptions when people are doing event sourcing. There are some terms that get confused, and we try to clear that up here, okay? And I will talk about some patterns that we found useful in our projects, in real-world projects. I will show you some traps that you will fall into and you should avoid probably because things get costly. This is not a Kafka rant. If you know me, I tend to rant in my talks. I do not do this here. I love Kafka. Kafka is an amazing product, just maybe not as an event store. But that's my opinion. And keep in mind that is for all the talks at a conference. What works for us might not work for you, and the other way around. I will not try to sell you snake or easy solutions, so keep that in mind, okay? And as I have only got 47 minutes left, I can see on the screen down there, we can only cover the tip of the iceberg. If you want to know more on each topic, feel free to come to me after the conference, this evening, whenever, and ask about it. I saw that a couple of you already are doing event sourcing. Nevertheless, I want to cover some basics. Namely, I'm a principal architect, so let's talk about event sourcing from an architect's perspective. Why are we doing event sourcing? Well, everybody's building microservices, obviously. And then you have to answer the question, how do these microservices actually communicate? How get data exchanged? And the easy solution is, of course, buy a giant database that scales vertically, put it in the middle, and let everybody integrate via data. Works awesome if you have licenses and you earn with those licenses. Then there's another different approach, where like you have different microservices, they have each their own database, maybe Postgres, something like that, and they communicate via messages or via HTTP. Might work. And there's a different solution, namely enter Kafka or another event source, anything. Just something that can store events as the golden source of truth for your domain. And then the microservices exchange events and and then there's a read model, super easy everything. And that's put in a data lake because everybody needs a data lake. Who has a data lake? Oh, I wonder why. And that's where the discussion stops. Never mind the details. Just a couple of events, read models, what could go wrong. And that little guy, just the magician, he will help us in my talk. So event sourcing, the basic terms. Event sourcing is actually founded in domain-driven design. So I would expect when you're doing event sourcing, you're doing domain-driven design. I can't imagine a different way. Then we always use event-driven architectures when we are building event-sourced systems, not the other way around. Event sourcing is not an architecture. Event-driven is the architecture. And last but not least, I've never seen a monolith built in an event-sourced way. Maybe there's one outside. If you're building one, tell me. Usually we use it in distributed systems. So again, we start with our domain. We find the bounded context that will later be our microservices, right? Then we find the important names. That's basic object-oriented analysis, nothing new. Then we try to find the dynamics in our system, in our business, like user onboarded, transaction booked. Those will be the events in our event store. On a technical level, we have events, something. We store those events in streams. So streams are a collection of events. Those things are stored in an event store. So do not confuse event store with the product event store. Event store is a general term. You can use a MongoDB as an event store. You can use whatever you want as an event store. You'll be maybe not successful. And then you can use projections. Projections are some kind of code that takes the events of the stream and computes the aggregate. We will look into that deeper later. And that aggregate can be stored in a read model. That's the general understanding there, at least from my perspective. Concrete example, we have as an event the user onboarded. User onboarded is stored in a stream specifically for me, user David. We use as a product event store. It's an open source project. And if I want to know the current David, we can build with some logic the David at the 19th of November at 8 o'clock in the morning. And our read models, we store them in Postgres. Easy. So once again, we have our stream. Events are ordered in the direction of time. User registered, user onboarded, user relocated, stream, event, payload. That's just terminology. Once again, an example for a projection. We have our stream, and the projection is basically a collection of handlers that's able to eat up the events in the stream and build a user aggregate at a certain point of time. So in conclusion, event sourcing is just the answer for how we can handle data in distributed systems in a scalable way. One giant monster database will not get you far, I can promise you that. And which is far more important, using events, everything, I can't speak when he's taking pictures. Everything you're doing in your domain, your business, is a first-class citizen. So basically, it's decoupling on a business level. So, read models. Reading is important, but read models are highly overrated. You might not need them. Read models are, that's an awesome description actually, are local hybrids of the events stored in specific streams. What does that mean? As I said before, we take all the events in the stream and we basically left fold with a collection of handlers. Nothing difficult there. But we saw that current user, David, at a certain time, what can we do with that thing? And just the magician has the answer for us. Every microservice gets its own database, right? So we have a user microservice that takes care of users. And let's insert what's a cool SQL store? Postgres, of course. So we insert a SQL store, and here's a representation of what I mean. You can see the user table, and we have the user ID, and we remember the last event ID, and there are only 3 events, so the last event ID that we read is number 3, and we have David with a certain email address. Easy. And if another event arrives, we just update that SQL store, right? Easy. Event number 4 and the new email address. And the cool part is, let's say we don't need a SQL store, we want a graph database. We throw the database away and whoop-de-whoop, there you have your Neo4j. So, end of talk. Maybe not. There are challenges, namely eventual consistency. It is an awesome concept. Everything is eventual consistent, actually, but it's a pain in the neck when you try to debug those systems Friday evening, 11 o'clock. So just imagine an event arrives, and there has to be some logic that actually updates the SQL store. So there's a time delay between that. And if you try to read that things, you have to build complicated systems. Then what about, I just mentioned, we throw the SQL store away and build a Neo4j. Instantaneously? I don't think so. So you have to come up with some solution how to deal with replays and rebuilds. What about redeliveries? I have yet to see a system that actually works with exactly once deliveries. If you have one, tell me, I would be grateful. And your ops guys and colleagues will be super excited if every microservice gets its own database. In Germany, where we are rather cautious with our data, so you get not the complete freedom there. So, but the good news is you do not need a read model. Read models are totally overrated. And that depends on the strategy for storing events. What is the general advice when we look at storing events? Typically, it's like this. We have all the events for users in a user stream. Super easy, so we can find everything. If I want to know something about user A, I just run through that stream and read all the events of user A. Maybe not. Maybe there's a better approach. Maybe we could just introduce one stream per aggregate. I get my own stream, you get your own stream, he gets your own stream. Everything is with its own stream. And the good part is, if you look at it, each stream is super small. There are 4 events, 6 events, 10 events, and that's what we find in practice. Usually, if you construct your aggregates in a nice way, in a sane way, your streams will be small. Of course, there will be streams that are rather large. We'll come back to that later. But in general, streams will be small. And then when we try to get the current user, like user B, we actually read the stream each time. We declare our handlers, yes, JavaScript, I have no honor left. And we actually read that stream each time. There's no framework, that's actually just what we write. We read the aggregate from stream user B, and we start at the head of the stream, and we apply the handlers. And whoopsie-whoops, we have our aggregate. No magic involved, no concurrency. It's consistent. We don't have any extra databases. And the programming logic is super simple. I love simple logic. But what about speed? Sounds slow. Actually, it isn't. It's super fast. Here's an entity with 100 events in it, and we take 66 milliseconds without optimizing. And let's say that's a user stream. What did that user do? Change his name each day? I don't know. So your streams will be smaller and your speed will be faster. And do not forget, we are talking about data that is immutable, so you can use heavy caching in that sense, if you have the need. What about queries? We can't query a stream, right? I think Kafka has now KSQL, or what's called KQL, but Eventstore doesn't. So let's say we want to have all adult users. Then we can build a projection. And the Eventstore, which I'm talking about, has an option to actually aggregate all the events from all users. That's a category projection, never mind the details. The idea is we have our projection, and we let that projection collect all the events that we need. And then we can use the adult users projection like we did any other stream and read just that. So it's basically a manifested query. Just remember, your event handlers are neither CPU nor I/O intensive, usually. Most of your handlers will just be getters and setters and getters and setters, nothing else. Keep your aggregate small and you will be happy. And please, by all means, before you introduce some database, because some paper said you have to measure and then optimize, not the other way around. So now we know how to read from an event store. We know how to get our data. But how do we write data? And especially, how do we guarantee correctness in that sense? Let's talk about an example. That's a typical banking example. We are only allowed to withdraw money from our account if our account holds enough money. And actually, of course, banks do not operate that way. Banks love if you overdraw. That's their business model. I should know. The first thing we need to realize is that the correctness of whatever we are doing depends on the order of the events. Here's an example. We deposit money, we have 100 euros, we withdraw 10 euros, then we try to withdraw 97 euros, obviously illegal, gets rejected, and then we once again deposit 50 euros and we end up with 140 euros. If we shuffle the last 2 events, it's a different picture. Then we can actually deposit 50 euros, we get 140, and then we can withdraw as we wanted. Can we use a read model in those cases for fast validation? Like, let's say we want to make sure that we update only if the account holds enough money. Well, that wouldn't work also. So, but that would work if your systems were single-threaded. Who's building a single-threaded system with only one instance? You are? Really? Okay, not bad. So it should be obvious. Yeah? We have two instances of the same microservice. One gets a request, checks if the account holds enough money. It does. And at the same time, basically, the other microservice checks also, and it's also okay. And then both withdraw money at the same time, and your account goes up in flames. So validation against the read model is always prone to inconsistencies. And what's the general advice there, of course? Our magician has an advice. Just put a simple database in front of your event store. Works like a charm. And that's awesome. And here's a link to one of those papers, and I'm not hitting on Confluent. That paper is actually pretty nice. And describing how to put Couchbase in front of Kafka so that you end up with a real single source of truth. So just a database in front of your event source store, and off you go. Yeah, and if you have operations, here's a tip if you want to make good friends there. Go to them and ask them to install a production-grade Kafka and Couchbase on AWS within, let's say, 4 weeks. They will hate you instantly. Is another way, yeah. Just realize that the aggregate is responsible for enforcing business invariants. That's just domain-driven design. The aggregate in our case is the account with the current balance of 30 euros. Yeah? And if there's an event that says, I want to withdraw 50 euros and I want to get into that stream, our police officer actually enforces that that event will not be accepted. So basically, the aggregate is a transaction boundary. Who is using Hibernate? Is that still a thing in Java land? Oh, 30%, I guess. So you should be familiar with that, and you can go to sleep. Optimistic concurrency control. Who has never heard of that? There's some people, so good that I explain it. Optimistic concurrency control is nothing new. It's just a basic concept that we think that we can do multiple things in parallel, and in most cases, they won't conflict. And each transaction is running verifies that the state it's going to update is actually the same it's read before. Super easy. What's the happy path in event sourcing? We have our stream. You can see there are a couple of events. Money deposited is the final event with event number 5. And I want to execute some business logic. So I build the aggregate as always, and I have to remember the event number. That's the important part. That's used for optimistic concurrency control, like the version field in JPA. So we remember that thing. We execute our business logic, and we want to emit money withdrawn. Before we do that, we compare both version numbers. They are equal, and ta-da, we can enter the stream. No problem there. The not so happy path is trivial, basically the same thing. Here you can see the last event number was number 4. So we build our aggregate. We try to do our business logic. We, being good citizens, we remember that ID. Then some sneaky person inserts another event into that stream with the number 5. So then when we try to compare both version numbers, we see that they don't match up. And when we want to emit money withdrawn, we can't. So that thing gets rejected. That's optimistic concurrency control in streams. So when we want to update that thing, an account with the number 1, 2, 3, 4, it's the same thing as before. Super easy programming model. We read the aggregate, we remember the last version number, we execute our business logic, and then we emit the events, passing in the last version number that we read. Super easy, no magic involved, no frameworks. And what about Kafka? Can we do that there also? I guess maybe there's some extension. I've checked their Jira. And there's this nice Jira ticket 2260, where a person requests the ability to specify an offset, like a target version before producing an event, which the proposal actually says would be very handy if you're building event source systems. But obviously people think differently, and it's of minor priority and still open, so I wouldn't bet on it. So with OCC you get scalability without locks. You get consistency for free. It's a design choice. You can use it where it makes sense. Maybe you have streams where it doesn't matter if you just append, and you don't have to check it. And no frameworks. You will get this often in this talk. I hate frameworks. So now we know how to read, how to write. What about versions? We Java developers, we love versions. But how can we deal with versions without going crazy? What's the general answer in Java land? What do we use? Of course, semantic versioning, right? And types. So the producer emits events and then an account stream, whatever, those green events. And being good developers, we like reuse, we share them, we put everything in one jar for reuse. And our consumer, on the other hand, that wants to read that stream, can easily reuse that event jar. Super easy. Then we change some types. Also super easy. So the producer produces money deposited version 2. Puts them in a new jar file for reuse. But our consumer doesn't use that. What will happen? Our good friend, the invalid class exception will happen. Our magician has also a solution there. Just double write. It's a technique you will always find in Eventsourcing Made Easy papers. Just write both versions. Money deposited and money deposited too. Why not? The problem is for the consumer. When reading that stream at a certain time, the consumer doesn't know, should I process this version or should I wait for another version which might or might not arrive? So can't actually decide. And on the coding side, when we have all these different versions of an event with all those different handlers that have to be written, that sounds like fun. Yeah, right, because in that case we can use something like an opcaster. I think somebody here familiar with Axon, with the Axon framework? So you have to, I think Axon has something like an opcaster for you. And the idea is basically that that opcaster sits between you and the stream and is able to convert events from a certain version to a different version so that consumers only need to basically consume a certain version. So the complexity goes into the opcaster. But 5 months later, you will typically find that the opcaster gets really complex, and I don't like debugging complex monsters. The fact is that we at least dropped versioning our events. We don't do that anymore because it's just a fact of life that a new version of a new event, must be constructible from the old version. So let's say you introduce a new field, like shoe size when you want to open your bank account, then there must be some kind of a default shoe size. Otherwise, we declare it's a new event, and then you have to handle it differently. It's an easy way for scaling, actually. But when we not store classes or objects in our streams, what can we store? Well, we've done some research and came up with a solution. Simple text-based human-readable events, which is fancy speak for JSON. Yes, JSON, not YAML. And it looks like this. This is not the actual structure of our events. It's similar to that, and you see it's basically human-readable. I can give it to you. You will understand what's going on, and that's not a real IBAN, I know. And you see the event type, you see the aggregate ID, and everybody knows what's going on. But JSON, no types, terrible. What about correctness? Yeah, actually, stringly typed events work really well. I know I will get burned for that later, but it works, actually. And if you need, there's something called weak schema, which we actually use. It's JSON schema. Looks awful, but works. You can, oh my God, I see the title of that event. It's terrible. You can declare the title of your event. You give some description. You can declare all the different attributes contained in the payload of that event. Like in this case, the new user's ID. And you can even declare a format and so on and so on. And in our systems, only the producer asserts the correctness. So when you actually want to send a new event or emit a new event, you assert, that's AGV, that's a Node.js library, you assert that the event actually conforms to that schema. And then everything is fine. The client does not have to recheck, it just accepts. So basically you could say that we use that schema as a description, not as a contract. The contract would be on both sides, but we trust the sender. Now that we know how to send and send and send and send and emit large streams, what could we do if we have large streams? I told you in the beginning that mostly your streams will be small, and that's the case, but there will be cases like a transaction ledger, which will grow. How can you handle event data over a long period of time? Actually, you don't. Actually, the magician is right on track. He suggests creating snapshots. Of those people who are doing event sourcing, who is building snapshots? Anybody here? I would really like to talk to you afterwards. I would like to how you do it. Actually, we do it a little bit differently. There's something that's called a year's end procedure. It's from accounting. And if you want to know anything about event sourcing, always go to your account department. They will know everything. It's basically a procedure that they apply to your bank accounts. If you look at your bank account, you don't get all the transactions from ever. You just get them over a certain period of time, like 90 days or 100 days, depends on your bank, I guess. So what they do is, at the end of a certain period, they compress your account into a new starting point. Like, okay, and the 1st of January, David has 15 euros on his account, and off you go. And the same can be done in event source system, and that's called copy transform. I like to call it event sourcing refactoring power tool. Copy transform is basically a giant hilti. How does it work? It's actually pretty simple. Let's say we have our transaction ledger for 2017 with all the different events, and imagine many events. And now there is a new time period, namely 2018. What we do is, once again, we compress the state into initialization state. That's like building an aggregate of a certain time period. That's basically my account at the end of the year 2017. Then we emit a deactivation event to the original stream. We link both streams. We do not delete the other stream. That's really important because you might want to generate reports across multiple time frames. And once you have done that, you can start actually emitting events to that new stream, and off you go. For microservices, it's also possible. Like at runtime, you have the old stream, and you start your cleanup period, your year's end procedure. You have the deactivation event and the initialization event. And since that deactivation event contains the link to the new stream, the transaction ledger can just switch over. Easy, right? Well, maybe not so easy, because that little switch, which I indicated with those arrows, there's some magic involved. If you can shut down your systems when you do that for a couple of seconds, it's easy. If you have to do that at runtime, things get messy and you will get gray hair like I have. It's basically the same idea if you want to remodel your domain. Let's say you have something like this, and I find that all the way. If you don't remember anything of this talk, it doesn't matter. Remember just this tiny fact. If your event contains something like blah, 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 and blah, 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 then it should be 2 events, not 1. So let's say we have that, transferred and booked, and we want to fix that. That's the same idea. Once again, we introduce a new stream, we initialize it, we copy the complete data over to the new stream, and then we basically copy transform the original event into 2 different. Works like a charm, and we can deactivate the old stream. Works like a charm without a framework, works out of the box, basically. Just the question is, at runtime or not at runtime. The devil is in the details, actually, to be honest there. Dealing with errors. The problem with event sourcing is always, which I get told, is that we can't fix errors in the events, right? Like, in this case, that's actually from a concrete project of mine, where the business sides decide not to enter actually ISO codes, but they wrote euro and British pounds and whatever. Yeah, we didn't find that soon enough. So let's say we have that amount and it's not an ISO code, and we only support ISO codes. We could just update the event store, right? Let's say we've built on Postgres. Yeah, sure we can. Look at here. It's just update transactions and set currency. Super easy. Early break. Well, maybe not. Don't do that, even if it's easy, even if it's supported. Let's say we have a consumer, and that consumer consumes all these events, and then you update the 3rd event, and the consumer is like, meh? I already read that. I won't read that again. And maybe the consumer has executed some side effects because of that old event. So, woo. Yeah, then we just use compensation actions. Anybody here back in the day when we modeled with graphical interfaces, we modeled with XML or web services, is that still a thing? And there was always this compensation action, which is super easy, and nobody ever did that correctly. Well, you can do it correctly, and that's, once again, from accountants. It's the cancelled or corrected event, and there are 2 different flavors. There's a partial compensation, which works like this. let's say we have our buggy event. We emit a new event, money transfer amount corrected, and we refer to the original event, and we just submit the amount as correct. I do not recommend partial compensations. They are not easy to understand. If you look at your stream in 2 years, you don't know what's going on, you have to understand the complete history. So let's do as consultants do, as accountants do, full compensations, nothing else. It's the same with your bank. Let's say I transfer 100 euros to you, and I use the wrong account number. They won't correct their account number, and I hope not. They will cancel the transaction and create a new one, maybe. So once again, our buggy event, we emit a cancellation event, which makes it totally explicit, and then we can reinitiate our business transaction. Why is this better? I told you, it's obvious. The reason for compensation is explicit. There's no hidden agenda, there's no magic, there's no, I have to dig through logs. It's clearly stated, cancel the transfer of money. Bless you. So, the last and the most fun part, actually, GDPR compliance and event sourcing. Who has never heard of GDPR? There's actually a couple of hands raised. Where do you live? GDPR, if you work like myself for the financial institutes and insurance companies, GDPR is really fun. And there was a colleague of mine who was super happy that he reduced the number of policies from 4,000 something to 2,000 something. So good for him. I am not a security expert, but actually as a German citizen, I like GDPR. GDPR is good for myself. I don't mind signing at my doctor that he can keep my email address, but I would like that certain other companies would be more, how do I put it, careful with my data. So GDPR, what is it? It's actually a regulation of the European Parliament and of the Council of 27th of April 2016 on the protection of natural persons with regard to the processing of personal data and on the free movement of such data and repealing directive. I'll stick to GDPR, okay? That's the title, the actual title. So I'm not making this up. I've read that whole document, it's awful, but the only thing that's relevant is actually Article 17. That's what we are going to talk about. That's actually the right to be forgotten. You can go to any company, at least in the European Union, and ask them to delete everything, basically, that your data, I'll come to that point, what your data is later. You can ask them to delete anything without any undue delay, and this undue delay is, yeah, it's nice. There's one solution that's sometimes proposed, just encrypt the stream and throw the key away. Yeah, it's super easy. The idea is every stream has its specific key. We use that key and nobody can read it. So we have 3 different streams, lilac, yellow, and green. Lilac key, yellow key, and green key. So you need that key to unlock that stream so you can read all the data. And when a user demands to delete all this data, you just have to throw that key away. Super easy. So we kill that key, all those events are away, and we can't read that anymore, right? And I think there, once again, Axon has some support for that, I believe, yeah? Right? Super. Yeah, maybe not a free lunch. Maybe there are challenges. I have yet to see a key administration tool that's fun to use. You know, they're always a pain in the neck. KMS is a pain in the neck, although it works. And working for financial institutes in Germany, they don't use KMS. They use something built internally, which when you have to wait for a key for 6 months. So maybe not the best thing. Then there's the point you have to find what you want to delete, actually. You have to look through all the streams, and depending on your stream and event strategy, finding what needs to be deleted is actually difficult. There are storage implications. Okay, in the cloud age, storage is actually maybe not our biggest problem, but nevertheless, there is. You are gathering garbage data. Coding complexity, depending on what you are doing, whether or not you are working in a polyglot environment like we are. We're not only using Java, so we are using JavaScript and Python and everything. You don't want to rebuild a framework for encryption and decryption every time. And most important, it's really difficult for operations. If you want to debug what's going on, handling out keys is really, really an issue. Turns out being able to delete is kind of cool. Databases are doing some things right. Yeah? Concrete example, let's say we have 3 different microservices that somehow relate to each other and we want to delete all data. What we can do is we actually can use tombstones. It's a super easy concept. It works actually like this. Let's say we want to delete the user 456. When that happens, the bank account service gets notified that that user was deleted. Then we can clean up our bank account data and we can emit that to the outer world. Eventstore once again has a solution for that. That's a special stream that you can subscribe to, and that will contain all the events that relate to the deletion of a stream. Whenever a stream is deleted, you will get a stream deleted event in that stream. So those microservices can listen to that. Here's once again an example. We have our user microservice. It asks the Eventstore to delete that user, so we can delete that user. And then the Eventstore emits that tombstone event. The bank account microservice, in turn, listens on those events. It listens for deletions of users. The bank account microservice knows which bank account belongs to that user, and it can ask Eventstore to delete that stream in turn, which it does, obviously, and then emit a new tombstone. Super easy. Event sourcing and GDPR solved with the right tool. But what about if I delete my Confluence account? Let's say we are all using Confluence as a wiki. Let's suppose we do. And my account gets deleted. Should my editing history vanish? Should my pages that I've created, should they vanish too? Or is just some separation? That is basically the question. What is if you have events that are related? If I transfer money in my bank from my account to your account, and after that I cancel my account at that bank, that transfer is not vanished. That data is still there. So one technique you can apply is the public-private data. It's a simple technique, actually. You just split public data and private data of the same aggregate. So in the upper part, you have a technical ID, which is generated, and my favorite color, yellow. And then there's a private stream where my name and my license plate, and that's not my license plate. And when you want to delete something, you keep the public data and you delete just the private data. So you can link up all the events and you get your complete tree. You may be able to keep that data. May. I can't tell you for sure. That advice that just anonymize doesn't work, not with GDPR, because there's a recital 26, which often gets overlooked. And it basically states that when you anonymize in a way so that you can trace back to the original user, then it's not anonymized, then it's personal identifiable data and has to be deleted. So surprisingly, no easy answers. But I can tell you, ask your lawyer or your security officer. They will know and they will be afraid and not help you. So that is already. I have to insert a cat picture, otherwise it won't work, actually. We need a couple of minutes more longer, so don't go away. Event sourcing, domain-driven design belong together. I have no idea if you separate those two, how you would. Who is not working in an agile process? Everybody is working in Scrum or something else? Be honest, you're among friends. We won't laugh at you. But honestly, if you are doing like 2-week sprints or 1-week sprints or 3-week sprints, I sometimes have the impression that we have not enough time to really think through complex architectures and evaluate where we are going. It's hard to find time if you are running at a high velocity. So event sourcing might need more time. You might need more time to see how you want to cut up your streams, how to want to build your aggregates. The good news is you can refactor. If you have made some bad decisions in the past, you can refactor your streams, you can refactor your events. That's possible. Copy, transform, that's your solution. I find that there are not enough in-depth books in general. Event sourcing is either discussed on a Hello World way or in crazy academic papers which are too hard to read, at least for me. I don't want to make enemies here, but I avoid frameworks like hell, at least in most systems that I build now. I like simple tools, simple libraries, and especially if you are building polyglot systems with many languages, I would rather recommend to stay away from frameworks and prefer libraries. And last but not least, never trust somebody who tells you blah, 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 made easy, or just do following. It's never just. Just is just the first page, and then hell, it's always that. Yeah, I've been burned in the past, so. Anyways, forget everything I said. Rather go to the bookstore, read some papers. There are a couple of good ones, actually. Each one is highly recommended. Top left, you will find the dark side of event sourcing. That's actually about schema migrations in large event source systems, and that discusses in depth what you can do at runtime if you shut your systems down, what's the implication, la la la. Really, really great paper. Below, who doesn't know Von Wern? Anyone here? Everybody knows Von Wern? Okay, cool. He's one of those poster people of domain-driven design, and that's a series of papers, PDFs, openly available, for modeling aggregates. That thing will change how you design your objects. Promise. The thing in the middle is a new book from Greg Young. Greg Young is also one of those masters of event sourcing, and it's published on LeanPub, so it's not really finished, but it's already a great read, and most of the proceeds go to charity, so instant buy, I guess. And that's about versioning an event source system. Everything I know from him, basically. And last but not least, there are some people from Microsoft here, and I was wondering if they still know that paper, which is actually awesome. It's basically kind of a diary of a project or projects that try to adopt CQRS and event sourcing and how they approach that topic. It's kind of dated, but still a good read. I've mentioned it a couple of times. Choosing the right tool is essential. We chose EventStore. It's an open source tool, not a framework. It's an open source tool that it's written in C#, gets compiled with Mono and runs on Ubuntu, which is kind of scary if you ask me. But what do you say? It works like a charm. And the documentation is awful. I have no idea why they're writing it like that, but the community is awesome. The developers answer all the time and select their answer on Google, so you don't have to be afraid to ask stupid questions. So yeah, great tool. And that's basically all. Thank you for listening, and please vote, give ratings, and not only at Devoxx, voting is important. Questions?